All right, this is section we're going to call 8.5. It is 8.5. Actually, part of it is in our book, but part of it's not in our book, so I have to give you a special worksheet afterwards. This is the last section in chapter 8. We've done volume. Now we're going to do surface area. But before we do surface area, we have to do arc length because the arc length is involved in the surface area. So this first part here is you see a little picture of a curve from the point AC here to the point BD here. I'm going to tell you that I could write this curve as y as being a function of x, so like y equals x squared, but it could also be written as x equals square root of y, just depending on what you wanted to. So this is an example, just like volume, where you could, rotate, or you could draw your rectangles any way you wanted to. Remember, for volume, so you could go dx or dy. It's just kind of the same thing here. You get your choice. This is just formula based. So today's homework's gonna be really simple. It's just formula based, and you can just use your calculator on all the integrals just to save yourself a little time. No problem with that. The book's going to actually ask you to find exact answers, but just use your calculator. Do not worry about exact answers. The integration is too long. So it's just totally formula driven. Got to memorize the formula. There's going to be a lot of formulas today, and then there's a lot of formulas in chapter 9 also. Nothing super, super hard, but it's all very formula driven, so you got to be a little bit careful. So this is a formula for arc length, L for arc length. I'm going to go dx on the first one, so it's the interval from A to B right here. So we're A, x is B, so we need the x points because we're doing dx. And it's simply the square root of 1 plus the derivative squared, written in terms of x, okay? Take the derivative of the function, square it, add 1 to it, put under square root, and then integrate it. And again, just use your calculated integrals. Most of the integrals, unless they're really forced, aren't very pretty anyway. You can make some so they're sort of pretty, but most of them aren't. You also have an or here if you determine that you want to do it in terms of y, whichever is easier, basically. If you're using a calculator, it's not going to matter a whole lot. If you're not using a calculator, sometimes it's easier to integrate one thing versus another, but it's hard to know that beforehand anyway. So all I did here was switch to dy. So you see the dy, which means I have to use the y points, which are c and d from up here, c and d. And then I still take the derivative, but this time you'd be having y's in your derivative instead of x. So that's arc length. It's going to pop up. So you will get asked a couple questions on the homework tonight, just a couple, just to find the arc length. Again, just use your calculator. Okay. And then the next part of this section is the worksheet part of it, is surface area. So now we're going to take this same arc length and we're going to revolve it. We're going to make a three-dimensional shape, but we're not going to find the volume of that three-dimensional shape. We're going to find the surface area. So it's going to look and feel similar, but the formula is different. So first, we're going to rotate it by the x-axis. For these problems, we're only going to rotate around x or y. We don't move those axes of rotation because it's too difficult. And in this particular type problem, it's very different than what we did before. Is like you're not going to get to choose. If it goes around the x-axis, you must do things in terms of x. And if it goes around the y-axis, you must do things in terms of y. So the formula, it's just formula-driven again. So notice we're going around the x-axis. I'll do one example of this for you can see it. So we're dx. So it's 2 pi times the function in terms of x times the arc length formula. So when I say the arc length formula, we would plug that in right there. Okay. If we're going around the x-axis, and oops, sorry, I wrote it out again for you there. The next one, 2 pi f of x times 1 plus the derivative squared. If we're going around the y-axis, you have no choice. You must do everything in terms of y. Notice the form is exactly the same. It's 2 pi times the function. This times the function is written in terms of y times that arc length formula. This is also going to be important in chapter 9 when we do parametric. It's going to look and feel similar. So all formula driven today. You basically have 4 formulas, but it's really just 2, right? With the arc length and the surface area. So I'm just going to do one example problem so you can see it. I'm not going to integrate it for you. I'm just going to set it up. Again, you can use your calculator to do the integrals. So we're going to rotate y equals x cubed about the y-axis. Okay, y equals x cubed about the y-axis. And we're going to rotate it from 1, 1 to 2, 8. So we're going around the y-axis. So remember, as soon as you hear around the y, if you're doing an arc length formula, by the way, right now, you could solve this any way you want. You could go y, well, I would leave it right as it is, right? It's already an x cubed, so you'd probably leave x's if you're doing arc length. But we're not doing arc length, we're doing surface area. So I guess I should say that, sorry. Find the surface area. All right, so now because we're going around the y-axis, we must keep everything in terms of y. So we're going to be using this formula right here. So since we're in terms of y, we're going from 1 to 8 on the y's. 2 pi, I'm just going to factor out, times the function in terms of y this time, right? So now I have to solve this for y. So maybe I'll come down here. So we're going to go x equals y to the 1/3. So my function is y to the 1/3. And then I need the square root of 1 plus the derivative squared. So now I take the derivative of this, right? It's x prime in essence now, because we're at 1/3 x to the negative 2/3. So 1/3 x to the negative 2/3 squared. Oh, that's y. Sorry, dy. I'm going to leave you to do the integral. The integral is not actually that hard by hand. It's meant to work out. But let's not do that for now. Let's just go ahead and use our calculators to find those integrals. So this is just straight formula, throw them in a calculator, find the answer. No matter what the book says, if the book says find the exact answer and integrate it, just go ahead and use your calculator, and you can check that calculator. The answer the calculator gives you the answer in the back of the book by just simplifying or computing what the answer is in the back of the book, because it might be like square roots of things or something like that. So, anyway, that's it for section 8.5.